Welcome to our next tutorial of Mesh2Surface for SOLIDWORKS. When we bring in a scanned mesh in SOLIDWORKS, normally they come arbitrarily in space. And what it means that if I place them into the standard views, as you can see, they are not properly aligned. Mesh2Surface for SOLIDWORKS provides some tools to help you to put them into the right position before you start. Placing this involves some understanding about coordinate system. What is a coordinate system? Is what you see at the bottom left of on the screen, and this is what we want. That, for example, the front plane to be this one, for example, and the top plane to be this one, and we need to place this. And before we continue, we need to have a little bit of understanding. So what we need here is to actually define this as a plane in SolidWorks. Then we need probably to get an axis here from this cylinder, and then we need another line here that defines our orientation. For the purposes of this alignment, we have a tool which is called Align Mesh by References. When you get to this mode, you can see how the coordinate system is defined, and we need to use the tools to place this in the correct position, and then when we press OK, the object will actually be positioned accurately. But we don't have anything now, so we need to actually create these references. For this purpose, we can use our tool which is called primitives, which will help us to extract these primitives from the scan data. We can start with the mesh selection in this case, and I will use the magic wand and I pick this area at the bottom. I can press OK, and then I can go to primitives. As in this example, this is a plane for me. We support for now 4 primitives, which are plane, cylinder, cone, and sphere. Why do we use them? Because they have important information such as axis of the cylinder or a cone, the center of a sphere, or the plane. In my example, this is a plane. I just press the button to tell the software to actually approximate the selected triangles, and what the software does is actually uses a best fit to generate this plane. The question now is how good this plane is. Is it accurate or not? And as in all other tools, we have the analysis option where you can turn this on, and then you can see the deviation and how well this plane is defined. And when I'm happy with this plane, all I need to do this is just to create this plane as a SolidWorks entity. There are 3 options to create this extracted plane. It can be only as a reference, which is a standard plane in SolidWorks, but also you can create it as a surface. The solid applies if you have the other 3 primitives. We'll go in details in our different tutorial, because for now all we need to do is just get this reference plane. SolidWorks creates this plane as a reference, and you can just adjust here, but you can see that this is actually all I need for now. Now, because we don't want the user to switch forward and backward to the selection and come back to primitives, here, while you're still in the primitives mode, you can actually go and make your selection here. So what I need to do is just unselect everything, and I need to take my cylinder, because this will define my axis, and I press the cylinder. The software will automatically make the best fit. I can see the deviation, how well it goes through the points. As you can see, this part is probably deformed, but because we have enough points, this can define for us the axis that we need. And I can press create. And when we have a cylinder, it only creates the axis. Another thing that we will need for this alignment is actually another plane here, and I will unselect, use my magic wand, and will create my other plane. I press OK. I can just move the plane here, and as you can see, this is enough for me to actually define my coordinate system. I will just unselect my points now because I don't need them. But the next step that I need to do is actually extract this line, which is intersection of the two planes. For this reason, we will just use the standard SOLIDWORKS command. I will just select one plane, then using Control, we will select the other one. And from the features, I will create my line that it's an intersection of the two planes. And I can press OK. Now we have all we need to move on to the next step, which is to define our coordinate system that will align this object properly in space. Now, as we have everything that we need, we can move to actually defining our coordinate system that will be used to align our object. In order to do this, we just select the mesh object that we need to transform. Then from the Mesh2Surface tab, we can just click on the Align Mesh by Reference. So how this works is that it uses the three features that you select on the scene, and it will use them in a priority order to define this coordinate system. So let's think now, what do we want to achieve? What I want now is I want to take this plane and tell the software which plane this is, and in this example it automatically will suggest that this is my front plane, which is a OXY plane, as you can see on the screen. Now it's interesting that we provided constraint to this algorithm how to define the coordinate system, and as you can see, this is what it does. It actually defines a coordinate system, and it applies the limitation that this plane must be my OXY plane. As you can see here, you have an option here that it will flip the orientation of the other axis, of the remaining axis. As you can see, now Z points upward. But this is not enough. This is not what we want. The question now is, where do we want to place the next as a constraint? For example, I can take this axis, and as you can see, the software automatically places the coordinate system in such a way so it complies with the two constraints. This plane defines my front plane, and the axis actually is my axis along X, because this is what I told the software. But in this case, for example, I want this to be my Y-axis. As you can see, it applies now properly, and the coordinate system aligns the Y-axis along my axis too. I can inverse this and I got my coordinate system. But this is again not enough. I probably will need the third constraint, which will tell this software to constrain my coordinate system. As you see now, we properly aligned our coordinate system in the right way. But let's think about this. This is not what we want, because this is a cylinder. We probably want a little bit different, still the plane to be the front plane, but I want the z-axis to be through this axis 1. So that's why choosing the features in the right order is important. I will just reset this and we'll start again. I will just take this, and this is my OXY plane. But this time I will just give a priority of my axis 1, and I'll tell that this is my z-axis. You can see now that it applies that z-axis will always be here. I will just flip. I need to flip the orientation. And then I need to choose that I want the third option to be my y-axis, and I will select this. So in this example, we cannot inverse the z-axis, because this limitation is that the z-axis is only along the provided axis, But to invert this orientation, we can just use the first option here, that while the coordinate system lies on the plane, we need actually the other orientation to be upward. So as you can see now, we're nearly there. All I need to do is just inverse my orientation of this. And now this is what I want to achieve. When I'm ready, I'm happy to do this. I can just apply, or in some cases, you can type numeric values and actually add additional translation of my coordinate system along the different axes. In this case, I don't need to do this, and I'm ready to go. If I press OK, the software gives you a warning that it will transform the mesh and there is no undo operation, and just to make sure that you have aligned this properly. If I press yes, as you can see, the software transformed the mesh, but it cannot transform the entities created in SOLIDWORKS. They still remain in their original position. But let's see what happened now. I will just select these references and will hide them, as I don't need them on the screen. But now I will just place my object into the standard views, and I will explore how well we have aligned the object. For this purpose, let's just show all of them. And I will just extend so you could get a better understanding. You can see that here we have our coordinate system positioned properly. The origin is in the right place, and all the planes are aligned. Why this is important? Because in the next steps, when we reconstruct our cross sections, or we reconstruct our extrusion, everything will be aligned properly into the right orientation. This is all for now about how to align the mesh in space, and we will move to the next steps. Thank you for watching.